Now we are going to solve the problem number 8.8, which is given in page number 129. That is given in the lesson dual nature of radiation and matter. Okay, first I'll read the problem. A proton and an electron have same de Broglie wavelength. Which of them moves faster and which possesses more kinetic energy? So this is the question given. Okay, first you are supposed to know the formula. Two questions are asked. One is among the proton and electron, which one moves faster? Which one moves faster means you have to calculate the velocity. You have to compare the velocity. Second thing is you have to compare the kinetic energy of proton and electron. Two things to be analyzed. First, the required formula is, first you have to write the de Broglie wavelength of the matter waves. Lambda is equal to, already you have derived the same formula in the theory part. So lambda of the matter wave, that can be written as lambda is equal to h divided by square root of 2mk. Here k, that represents the kinetic energy. Make a note. H is the Planck's constant, m is the mass of the particle, k is the kinetic energy of the particle, lambda is the wavelength of the particle, de Broglie wavelength of the particle. Now two things are taken. One is proton. Proton, when compared to the mass of the proton is greater. Compared to the mass of the proton, mass of the electron is less. So mass of the electron is less, therefore we can write like this. Okay, mass of the proton is greater than mass of the electron. By drawing the diagram, you can easily understand. Now we are going to write the expression for both proton as well as for electron. I'll write it here. For proton, I'll write proton. Here you can write it as electron. Now I am going to write two equations. As per the clue, what is mentioned, de Broglie wavelength of both the two are same. That is lambda of proton is equal to lambda of electron. This is the clue which is given in the problem. Make a note. Now substitute, clear all the factors here in the formula. How can we write? Lambda for P can be written. How it can be written? H divided by square root of 2 mass of the proton and then kinetic energy of the proton, which is equal to, next step, H divided by square root of 2 mass of the electron and kinetic energy of the electron. So in that format we can write. Now we can cancel the common factors. Okay, now we have to split it. H divided by root 2 and then mp square root of m square root of k p can be written. So write it in proper form and then cancel. H square root of 2 square root of mass of electron square root of kinetic energy of the electron. So in that format first you write, later you can cancel. H can be cancelled, square root of 2 can be cancelled. The remaining steps are given here. Now we have to cross multiply the things. So what we have to do? Clear here, as given the textbook you have to write. So here this Kp can be written here. If Kp is brought here, Kp, Ke will be in the down. So we can write square root of Kp divided by square root of Ke. In that format we can write. If it is brought up, this one will go up. Are you clear? So which is equal to mass of the electron divided by square root of mass of the proton. Take square on both sides. So finally we will be getting Kp divided by Ke, which is equal to Me divided by Mp. So in that order you will get. Look at here, already I have told the mass of the proton is greater than mass of the electron. Or you can say that mass of the electron is lesser than mass of the proton. Look at here, this factor is mass of the electron is less, mass of the proton is more. If you divide this factor, you will get the fractional number. Are you clear? So this is lesser this is greater means that can be written like this. Mass of the electron is lesser than mass of the proton. So in the same order you have to write here. Are you clear? This ratio should be equal to this ratio. This is lesser, this is greater. Lesser number divided by greater number, that one will give the fractional value. Like this, this factor divided by this factor also will give the fractional value. So in the same order you write kinetic energy of proton must be lesser than kinetic energy of the electron. So finally, what is asked in the problem? Which one moves faster? Whose kinetic energy is greater? That is a question asked. So for the second question we can answer. From the expression, it is seen that kinetic energy of the electron is greater than kinetic energy of the proton. So we can write kinetic energy of the electron is greater than kinetic energy of the proton. So we can write like this. So the most important thing is the particle with the lesser mass. The particle with lesser mass means electron is having lesser mass. That one possesses greater kinetic energy than the proton, because proton it has more mass, therefore its kinetic energy will be less. So now we have answered the first part of the problem. Are you clear? So this is one of the conclusion that should be written. Are you clear? Now we are going to compare the velocity of the electron and velocity of the proton. This expression was already derived. Now where from we have to start? Now we are going to take the ratio of kinetic energy. Are you clear? So write the same thing, Kp divided by Ke. You have to write the usual formula, that is half mp Vp square. This is the expression for kinetic energy of any moving body. For that, clear, this formula is used for proton, divided by kinetic energy of the electron can be written as half me Ve square. So in that order we can write. Now we have to cancel the common factors. After cancelling these things, what you will get? This is the final expression. Now in this factor we have to compare the velocity. So keep the velocity factor in one side. Vp square divided by Ve square is equal to Vp square divided by Ve square is equal to, cross multiply this, Kp into Me. Are you clear? Divided by Ke. This Mp will come down. Are you clear? And then what you have to do? The same factor to be squared on both sides. So after squaring you will get Vp, this one to be squared on both sides. Vp divided by Ve is equal to, after taking square root, clear, what will happen? This Kp divided by Ke into Me divided by Mp. Are you clear? Take square root on both sides, finally you will get the expression like this. Finally you have arrived, Vp divided by V is equal to square root of Kp divided by Ke into Me divided by Mp. Look at here, this expression is already found out. Are you clear? Instead of Kp by Ke, which one can be written? This one can be written. This factor to be replaced by this factor. The next step we can write Vp by Ve is equal to square root of, instead of this part, this one must be written, Me divided by Mp. Already here Me, Mp is there. Me by Mp can be written. After that what will happen? Within the square root multiply Me square divided by Mp square you will get. After taking square root, finally you will be getting Vp by Ve will be equal to Me by Mp. So this is the final expression. From this expression we are going to arrive the final conclusion. Already we have seen mass of the electron is lesser than mass of the proton. This is already known. Are you clear? This is already known one. Are you clear? So look at here, if this one is divided by this one, that is smaller number divided by greater number, Is it clear? If you do the division, you will get the fractional number. Same thing will get here also. Are you clear? This one divided by this one will give you the fractional number. So from this expression we can write ME is lesser than which one? MP. In the same order you write VP is lesser than VE. So this is the conclusion arrived from the expression. But what is asked in the problem? Whose velocity is greater? From the expression we can easily say that velocity of the electron is greater than velocity of the proton. So therefore we can write in other form also. Velocity of electron is greater than velocity of proton. So this is the final conclusion that should be arrived. Are you clear? Very simple problem, may be asked in 3 mark. Okay, so two things are compared here. One is kinetic energy and another one is velocity. In both the two cases, kinetic energy and velocity, the conclusion is kinetic energy and velocity of the electron is greater than velocity of the proton. Okay, kinetic energy and velocity of the proton. That is a conclusion. Understood? Very interesting problem, very simple problem. May be asked in 3 mark also. Okay, thank you.